Okay, hello everyone. Let me set up the screen share. All right, hopefully this is visible. Let me check. Yeah, should be good. Okay, so hello again. Today I'm going to be presenting on Polkadot for Solidity developers. My name is Utkarsh Bhardwaj. I'm a software consultant at Parity. I started working as a runtime engineer, but for the past year, I've been working in developer experience, trying to improve builder experience for developers building on Polkadot. So let's start from the very beginning. So, what is Polkadot? So, Polkadot is a multi chain network built for a world where blockchains need to work together. So, rather than a single chain doing everything, Polkadot connects a growing ecosystem of specialized blockchains that share security, communicate natively, and upgrade independently without hard forks. So, this is like a technical definition. But what helps me understand this is a comparison to something of a Web2 service. So Polkadot is to Web3 what AWS is to Web2. So for example, in AWS, you have a service for identity and access management called IAM. Similarly, the Polkadot equivalent is PeopleChain for on-chain identity, credentials, and registration. In AWS, you have Lambda for serverless compute with no infrastructure management. The Polkadot equivalent would be Polkadot Hub smart contracts. So here you can deploy code without caring a bit about infra or chain or anything. For storage, AWS has S3 to persist your data. Polkadot has a couple of equivalent things. So we have the Polkadot Hub for assets, where you can hold, issue, and manage on chain assets. And we have the Bulletin Chain for medium term storage. So Bulletin Chain is brand new, but it lets you save files for medium term storage with auto renewals enabled or disabled, depending on how you configure it. And finally, we have EC2, where you run your application on rented servers with Amazon. So Polkadot equivalent is the Polkadot Cloud, where you run your own app chain and you rent core time to inherit Polkadot shared security and interoperability. But there is one major difference. AWS services are run by Amazon. You trust Amazon. On Polkadot, all services are trustless and decentralized. With that out of the way, let's move on directly to the Polkadot Hub that we'll be interacting with to do Solidity smart contracts. So Polkadot Hub is the entry point to Polkadot for all users and application developers. It provides access to Polkadot's core Web3 services, smart contracts, asset management, staking, governance, identity, and cross-chain interoperability without you requiring to deploy or manage a parachain. The point to note here is that the hub is not a single chain. It is a unified experience delivered by a system of specialized chains working seamlessly together. So, as a developer or a user, you never need to know which is the underlying chain handling what. So, as a user, you can hold, send, or receive dot. You can stake dot. You can vote in governance via OpenGov. You can create tokens or non fungible tokens or NFTs. As a developer, you can deploy Ethereum compatible smart contracts in Solidity using REVM with no tooling changes required. You can use PolkaVM for native RISC-V execution and higher throughputs when you need it. You can build dApps that tap into Polkadot's security and cross-chain interoperability via XCM. You can access governance, treasury, staking, multisig, identity features, etc. directly from your smart contracts using Polkadot precompiles. So then what is the Polkadot Cloud? The cloud is a scalable platform for deploying resilient, highly customizable Web3 applications. It is a set of functionality on Polkadot for teams who need to build and run their own blockchains. It has dedicated throughput, custom logic, full sovereignty, and it's for people who'd rather deploy their own blockchain rather than deploying a smart contract on the hub. So the core resource of the Polkadot cloud is core time. It is Polkadot's unit of block space and computation. So if you're building a DeFi application or say an NFT marketplace, the hub smart contracts are most definitely this starting point for you. The cloud becomes an answer only when you need things like dedicated block space. So you want your own throughput and you don't want to share your throughput with other smart contracts on the hub, or you want your own custom runtime logic. So you want first class palettes, specialized state transition functions, and not inherit the ones from Polkadot's. You want full chain sovereignty. So you want to add your own governance, fee models, upgrade cadence, and you want to scale beyond what smart contracts can offer. So basically, the Polkadot cloud is the natural graduation path from the Polkadot hub. So when you build your dApp, you start with the hub, and as and when you gain customers, need more throughput, need custom runtime logic, and things like that, you graduate to using the Polkadot cloud by renting core time from Polkadot. So before we dive into Solidity, there are two things we need to know first. The first of them is the dual VM stack on Polkadot Hub. So we've talked a bit about EVM and PolkaVM in the previous slides. We'll go into that in the coming slides now. So Polkadot supports two VMs, the EVM and Polkadot's native PolkaVM. So EVM is a Rust implementation of the Ethereum virtual machine via REVM. It runs your contracts byte for byte identical to Ethereum. It is production ready, everything works out of the box, full support for all Ethereum tooling. And then we have a PolkaVM, which is a RISC-V based execution engine that compiles your Solidity smart contracts through a native Resolcy or a Revive compiler. It has a higher performance potential through a future JIT compilation and much lower fees. PolkaVM is live, but it is still experimental with workarounds for gas mapping, Ethereum to substrate translations, etc. So if you want to experiment with PVM, the recommended stack would be to do Rust contracts with the PVM stack. Or if you want to do for this hackathon, if you want to do Solidity, the way to go is still going to be EVM, and because everything would just work out of the box. So why two VMs? The core ideology is to have immediate EVM compatibility with room for future innovation. So why not just support an EVM? Because PolkaVM unlocks a few use cases, like language agnosticism. So EVM can only support Solidity or Viper and a few other languages, but PolkaVM can support anything that LLVM can support. So anything that can compile down to RISC-V can be supported by PolkaVM. So you can write your contracts in Rust, Python, C++, and PolkaVM in general has a better architecture. RISC-V is register-based, 64-bit deterministic, and JIT-friendly, while the EVM stack is a stack-based virtual machine, 256-bit, and interpreter only. In our benchmarks with JIT compilation enabled on an internal version of PVM, it outperforms both EVM contracts and even WASM contracts. The second thing we need to be careful about and know about are accounts. So Polkadot natively uses 32-byte addresses, so SS58 addresses, and Ethereum natively uses 20-byte H160 addresses. The Polkadot hub, your entry point for smart contracts, bridges both. But the way it does has important consequences depending on how you created your wallet. So for Ethereum accounts, if you're using MetaMask or any other Ethereum wallet, you don't have to care about anything. Polkadot hub handles everything. Your 20-byte Ethereum address is automatically padded with 12 bytes to produce a valid 32-byte Polkadot account. You have nothing to do. Everything works out of the box. But if you have a native Polkadot account, the chain still derives a 20-byte Ethereum address for you by hashing your 32-byte account with Kechak256 and taking the last 20 bytes. But hashing is a one-way function. So the hub has no record of which 32-byte account produced this 20-byte hash. So to store this mapping, you need to call Palette Revive's map account extrinsic once from your Polkadot wallet to store this. Once it is stored, everything again works identical to if you would have started with an Ethereum account. So for the hackathon, the recommended would still be to use like a MetaMask account because everything would just work out of the box. You don't have to map your account or anything. The hub will manage everything for you. So now we can move on to the demo. The only thing you're going to need to follow along for this demo is your MetaMask setup. So you need to add a custom network to your MetaMask for this Polkadot Hub testnet. There are a few ways you can do that. So the easiest way would be to directly head to the documentation at docs.polkadot.com, go to smart contracts, and then just click on connect on Polkadot. You'll see this button on the top, and then you can just click on it to connect to the Polkadot Hub testnet, and it would set up your MetaMask with the Polkadot Hub testnet account. If you want to do that manually, then you just have to go in here at the network and go to custom, scroll down to the bottom, click on this add custom network and fill in the details here. The details are there in the documentation as well on the connect to Polkadot page, and they're also on the slide. I will wait for a second if you want to click screenshots, or the best way would always be to directly head to docs.polkadot.com. It would always be the source of truth. So moving on, once you have your MetaMask wallet set up, you need to get some test tokens so that you can interact with the demos or with the smart contracts in general. The way to do that is to head over to Polkadot's faucet. It is faucet.polkadot.com. In here, make sure you're on Paseo, which is Polkadot's testnet, and make sure you're on the hub. And then you can directly paste in your MetaMask address. You don't need to paste a mapped address or anything. Just directly copy your Ethereum address from MetaMask, paste it here, do the CAPTCHA, and just get some pass. And that should just work. So once you have your tokens, you can check on one of the block explorers to ensure you have it. Or another way is to just check in MetaMask. You won't see it on the balance here at the top, but in here in tokens, if you scroll down and go to tokens, you should be able to see some pass. Okay, so I'm assuming now that you have MetaMask set up and you have some test tokens. So let's go ahead to the demo. So Polkadot supports all the Solidity environments that are used, that are industry standard, like Remix, Hardhat, Foundry. In this presentation, we'll be going through two of them. But again, you should refer to the documentation for more information. We'll be going over Remix and Hardhat in this, but Foundry is also well documented in the documentation. Feel free to use it and follow from there. So let's define a problem statement. So this is for a hackathon. So you're all hackers. So imagine you're building a dev DAO for a community of open source developers like yourselves. You want to reward contributors with badges, and you also want the community to vote on which grants to fund. One approach would be to give everyone an ERC20 governance token. But ERC20 tokens are fungible, they're financialized, meaning they have monetary value, and they end up getting concentrated in whales. So whales decide what happens and not everybody does. So it's a bit gameable. The better approach is non-fungible tokens. So basically proof of contribution badges. So you ship code, you earn a badge. That badge has metadata about what code you shipped and why you earned the badge. And each badge is unique and has a voting power. So this sounds like a real world use case. Now, if you were to build this from scratch, you need to implement ERC 721. For the non-fungible badges, you'd need to implement votes so that each badge has like governance power. You'd need to implement pausable in case you want to pause the contracts. You'd need to implement ownable for admin control. And you'd need to implement URI storage so that you can store the metadata to each badge, which the front ends would use to display images for the relevant badges. That's a lot of moving parts. And here's the key insight. These are all standard battle-tested building blocks. You don't need to reinvent them. This is exactly what OpenZeppelin is for. So OpenZeppelin gives you audited, composable smart contracts. And they even have a wizard which supports Polkadot now. So the wizard is a visual configurator where you just tick the features you need and it generates the contract code for you instantly. So whenever you have these sort of reusable components in smart contracts, the recommended way to do is to check them on OpenZeppelin, because OpenZeppelin contracts are all audited and you can use them directly. So you can either scan this QR code to go to the OpenZeppelin wizard for Polkadot, or you can directly head on over to wizard.openzeppelin.com/Polkadot. So you mentioned we want to create a ERC 721 token, and it's for contribution. So I'm going to call it contributor badge. Let's make the symbol be badge. We want this to be mintable, pausable. We want it to have URI storage for images. We want it to have votes. And that's about it. So we can directly open this in Remix now. And we have our code here. So basically within like under 30 seconds, you're able to create a production grade contract and then have it in Remix. You can compile it and it works, and you can even deploy it. So for deployment, you need to configure the environment here a bit. So we need to use the injected MetaMask provider. So you go to environment, browser extension, injected provider MetaMask, and then that should automatically detect your custom network here. So now we can deploy this contract. So I'll copy my address, put it here, and just click deploy. Sign the transaction, and then we need to wait for a few moments for this to deploy. But then it should deploy this entire smart contract for you. So OpenZeppelin is always a good idea to visit first. If you have like these reusable smart contract components that you want to use, and then you can also use it for quick prototyping, or you can directly head on over to Remix and then just translate all your skills from the Ethereum environment directly onto here. I'm going to give it another 10 seconds. If it deploys within that, we can try to use some functions. Otherwise, we'll head on over to the presentation and come back here to check on it later. Okay, it's probably going to take a little bit of time. So we can head back over to the presentation. In general, you can make more updates to the smart contract for our problem statement. Right now, these badges are transferable. You can override the transfer function in your contract to make sure that nobody can transfer badges. You only get one when you actually make a contribution so that it's even less gameable. And that's how you can use like OpenZeppelin covered with Remix to do development within your web browser without having to install anything at all. Okay, the other environment we're going to be looking at is Hardhat. So Hardhat project setup is going to be completely identical to your Ethereum environments. Nothing is different here. So I've listed down all the commands that I think you're ever going to need in your projects here. But if you need more, you can always refer back to the documentation. So you can initialize your project with Hardhat in it. You can install the contract verification plugin. You can set your private key using npx hardhat var set, which is the modern way of doing it, or you can use environment variables. That works perfectly as well. So hardhat compile to compile, hardhat test to test, and then you can use the hardhat ignition to deploy your contracts using the hardhat ignition. And you can verify your contracts as well using the verification plugin that you'd install. So let's again define a problem statement that we'd want to solve with hardhat. So you might remember Reddit's R place. It was where basically millions of people created pixel art together on a shared canvas. So you can only place one pixel at a time, and then you have a cooldown of a few minutes. And so basically lots of people contribute to the board or the canvas together, and then the eventually when it's filled, the pixel art is built by like thousands of people working on the same canvas together. So when Reddit launched this, communities banded together to try to create art for themselves, like flags or anime lovers try to create anime characters. But Reddit controlled it. They decided when it started, when it ended, and they could erase the whole thing tomorrow. We could build something like that where no one owns the canvas, where every pixel is permanent and a traceable transaction on a public blockchain. That's what we'll look at today. It's called Pixel Canvas and it runs on the Polkadot Hub. So the live demo is right here. I created this yesterday and deployed it using Vercel. You can scan this QR code and it should take you to this website, and you can connect your wallet here, and then you can select a few pixels, like colors, whatever you want, and then place them here. You'll see all the activity in here, the different accounts that are interacting with it, and there'll also be a cooldown. Okay. So yeah, I'll let you have a look at this while I do a code walkthrough of this project. So this is open source. I have put it in the resources in the end. Maybe we can share the PPT. Otherwise, I'll stay on the slide for a second. So yeah, this is the main sort of code for this. Let's head on over to hard hat config. So if you've built anything on Ethereum, this is going to feel very familiar. We're using hard hat, the same toolchain you'd use with Ethereum, Solidity, hard hat toolbox for testing and deployment, and hard hat ignition for deployment. The only difference is this network config right here. So instead of using a Ethereum RPC, we point at Polkadot Hub's testnet, and that's it. Same chain ID format, same account setup. Basically, if you can deploy to Ethereum, you can deploy to Polkadot Hub. The tooling just works. You can compile with npx hard compile, test with test, and ignition deploy. Everything just works out of the box. We also have this config for verification. So under custom chains, we add our block explorer URLs, API URL, and browser URL so that you can use the hard hat verification plugin and verify your smart contracts. Now, let's look at the smart contract. So the main, the pixel representation is the struct over here. A 24-bit RGB color is packed into 3 bytes, and the address here is of whoever painted that pixel. So we also stored them in nested mappings over here. The core function is the set pixel. So it checks whether you're within bounds, and then it also checks whether you're within your cooldown period. So this cooldown is configured at this contract level, and it checks whether you're still within the cooldown period, and then it won't let you place a pixel. We count how many pixels have been placed by you, and we also count the total number of pixels placed. And in the end, we emit a pixel placed event. Now, emitting this is important because this is what we use to display the pixels on the canvas. So this pixel placed event is indexed by the painter. So you can query based on the painter, and then you can show it on your front end. The front end is a combination of React, White, Tailwind, CSS, and a bunch of things. I'm not a very good front end engineer, but luckily we have AIs these days to build this beautiful front end for us. So I see some activity here. People are placing things. So I can place something to just show how it works. You click here, you confirm, and you wait for the transaction to confirm. It's taking longer than it usually does. Let me refresh and try it again. So you can see even without connecting my wallet, I can see the canvas. And that is because we're using the events instead of actually querying the blockchain state. That's actually a good idea to do whenever whenever you want to do bulk queries or query like historical data. It's better to use events rather than actually querying the state. Okay, so okay. Let me see what happened here. Seems like I'm in a cooldown. Oh, okay, I see my pixel placed here. But yeah, probably because of that, I got in a cooldown. I'll try to do this again. Okay, I see the cooldown now. So yeah, once this updates, I guess there's people trying to place pixels in parallel. That's why it's also, I see another pixel popping up. I guess if the board is filled in by the end of tomorrow, we can put out a tweet that this pixel art was created by the hackers participating in this hackathon. But yeah, it's just a fun tool for you to play with. And all this to show that building on Polkadot Hub feels exactly like building on Ethereum. If you know Solidity and Hard Hat, you already know how to build here. The contract compiles the same way, the tests run the same way, MetaMask connects the same way. The project is open source. You can clone the repo. I'll attach it in the resources in the end. The README walks through the setup. So because this is all stored on blockchain, this canvas is like this. If you want to create your own, maybe a smaller canvas, bigger canvas, maybe you want to play with your friends, you can just clone the repo, configure a few things, deploy your own contract, and then you'll be able to use this. Okay. So finally, some resources. Like always, the docs are always your source of truth. We have worked really hard to keep them up to date. So, for example, if you see any sort of tutorial here, we have these GitHub badges, which basically test all the code in this documentation in real time. So this badge, if it's passing, you know for sure that if you run all this, it'll work, and because it's being tested in real time in a CI. So always refer to the docs.polkadot.com/smart contracts. The faucet link would also be in the docs, but it's faucet.polkadot.io. Be aware that you'll get rate limited, so you can't just have like 10 accounts funded in the same day. So be judicious with your use of the faucet. And then the open source project for this Polkadot Pixel canvas is here. So feel free to use that, clone it, create your own canvas. And that's about it. Happy hacking. Thank you. I see a question about why cooldown period. So if we don't have the cooldown period, then you can alone control the entire pixel board and paint it. The whole idea is that it gets painted by a community together. So that's why a cooldown period. But again, like you can clone the repo and change the cooldown period to 0. So in your version, there'll be none. So you can paint whatever you want. I see no other questions, so I'll close my window and sign off. Thank you, guys.
Okay, hello, can you hear me? Okay, yeah, let's get started. Okay, let's see who's sort of here. Okay, can you sort of here? Okay, uh, right, so, hello everyone, I'm Pinterest for joining the workshop of the Hackathon's product officer. I'm just really happy to be a part of the hackathons. I think you already left familiar with you because I presented typically I think more than 50 years already. So into the workshop, we're gonna start quickly. We're gonna talk about how to do the autonomous agents and something else, how to your code and literally has the architecture that we apply into the building. This better now. Can you hear me? Okay, let's continue. So into the workshop, we're gonna talk about how to build the autonomous agents and Polkadot. And um, like right now, everyone is shift into the AI. There's a lot of people interested in building the agent. But I'm gonna talk a bit about how you can integrate the blockchain and integrate AI into blockchain or in the blockchain into the AI. And so for the agent side, we're doing a measurements that is coming from the brand into the actions. So the autonomous agent and Polkadot is require specialized capabilities that with blockchain operation with AI reasoning. Unlike a traditional agent, they must navigate the decentralized governance, multi-chain and retail operations while maintaining the fixed context. Because in the blockchain space, the environment is different from the traditional infrastructure that the AI operate on. So the two key players, Benefit, the agent, and Polkadot is working on reasoning and change the on-chain execution and the communication experience. Because the Polkadot is popular for easy interoperabilities to different types of protocol. Um, and also on-chain execution where you have you have a virtual machine where you can secure the transactions on the virtual machine of the Polkadot, and that is executed to cryptographic secret. So I'm going to start with some traditional approach here when you do an agent. So when you do an AI agent, it's not very different from you do a normal AI agent in traditional traditional software. So when with a common framework here, I recommend for thousand framework. I recommend you use Langchain and LangSmith, which also the framework I use to build most of the agent I'm building right now. So for the LangChain framework, it's managed by the chain of thought reasoning and maintain the prompt history across the multiple blockchain chains. So the LangChain will provide the orchestration layer for the complex agent workflows um, Long is with like it has three people. The first one would be the state management, communication operations, from conducting the system restraint, and also team integration for like different kind of like blockchain operations. Management is more like a tool for you to observe all the response and also like to see the performance of see the performance of your agent's response yeah, like in real time. So like management traces the agent performance, reports the complexity execution needs, and monitor latency across like the networks. It's essential for the production grade agent deployment, execution phase, visualization, latency, error checking and A/B testing, perform optimization. So these are like two framework I highly recommend for anyone who wants to be an agent that uses take. Then the second concept, whenever you create an agent, would be a direct, retrieval augmented generation pipeline. So like when you do an AI agent, you would want like the agent to um, get get exposed to like the documents and also like if you upload a PDF or like you seek with different data sources across the internet, you need the agent to consume this data and then respond based on this data with different with with high using activity. It can have a good plan to respond with like knowledge base. So the red pipeline is like the technology that allows you to do that. The red pipeline is also similar to like other data pipeline. You get the process where you fetch the data from different data sources, and then you transform it. And also like then later you feed it into the agent brand. Then like in here, you can use different type of database for vector DB instead of like using a normal database like a relational database or a NoSQL database. Because like a vector DB is allow you to store the data in vector. And in that way, you can do different types of like similarity search or like hyper search over like the data stored in the database. Um, and the red pipeline it also you have different variants and different enhancement of the red pipeline where you can like process like different type of data, whether it's going to be just simple text or it's going to be like complex document coming from a PDF. So this ensures that like the agent will have accurate, up-to-date response based on current network conditions. And the red pipeline is it helps like the agents work with queries that understanding. This process the user intent, and then later it's going to identify relevant like blockchain operations needed for the agent to operate. Then a document retrieval that is fetches latest spec from like can be for Polkadot. You can do LLMs text, which is like the one way for yeah, you can like serve the knowledge base of the agent like through like the developer logs, the developer documentations of Polkadot, so that your agent can have more awareness over the data of the, and how the Polkadot operate. And then later we have the context generation with documents like the LLM in the current dynamic state and the technical documentation of Polkadot. Yeah, and here we also have a very basic, simple pipeline of the right. So like you have the document, then you're gonna do like the indexings. You can have different kind of method like SNSP, SNSP like indexings, and then like you do restore it to like the factory DBs. So like when the user query, it's gonna get to like the factory DB to do a similarity search, and how to search. Then you're gonna get like the top page right. And then you ship those into like the LLM brand. So like this step is called data retrieval or generations, and you get like the response generated from like the data is already retrieved from the red pipeline. Then do you know the part that I also would love to mention is in the agent memory. The agent memory is different from the context. For the agent memory, it must be something that the agent can remember. So you already familiar with that concept of the vector DB, where when this is also like a clear database in the red pipeline. But like for the agent memory, it's more like a brain of the agent. And for like the memory, you can also like imagine it similar to like the way that you do direct but like for engine memory, you can plug in like the memory engine in different ways, so it can be stored with like different types of format which already optimized for use case. And you can like use like agent memory and also the red pipeline at the same time, depend on the use cases. For example, like if I have a PDF file, I would love for it to be processed to the red pipeline. But like if I just want like the agent to remember the conversations, I would use agent memory. So the agent memory is used for intelligent and stateful instructions. An agent like require a purpose memory system. So this company like allow the agent to record the past conversation. For example, if I already mentioned that like I recognize something, I would like the agent to remember that and respond based on my preference. And the agent memory is allowing the agent to understand relational knowledge and leverage like long-term information for more sophisticated decision making. So there are three like different types of like concept in the agent memory right now. Based on my understanding, there is like more variant and more innovation in the space. But like from my perspective, I would love it to introduce like mem zero. So mem zero is a just sequence as time memory storage for managing the immediate conversational context and local data within an agent execution. Then like later you also like have the context graph. I believe that mem zero also like have context graph with the technology but where like context graph is our concept where like as you already know about like knowledge graph or like the graph theory, and like the data can be indicated, it can be stored and demonstrated in the graph based data structure. And in the context graph, it's also similar to that. It's break like a conversation into the smaller chunk and then map like all the conversation or the text into and visualize them into a graph. So the context graph is established in the semantic connection between the entities and the concept and enabling like the agent to understand the relationship and show like influences from the knowledge base. For that, like Zap is also a technology which also the field concept graph under the hood. And Zap is going to fit better if you use it for a long-term memory instead of memory. So Zap is a valid persistent storage for an agent experiences and learn like type and all historical interaction is similar retention across all the sections. Okay, so like those are like some concept of like building the agent. Like you have a framework, and like you have a direct pipeline, that you like get the data and integrate into like the agent framework. Then like, you have the agent memory where you can expand like the memory layer of the agent to the technology. Then how about like the tools for you to fetch data from the blockchain? Then you have the library like Polkadot API, where we also use create like copy, and then like copy physical validation type safe, type script library, where the copy provide a lightweight string type interface interacting with the network. That's just a low level of the secure into intuitive method while maintaining the type safety integrated definition. The key feature of copy, like I mentioned, is the auto-generated transcript type for the chain metadata. So it's sort of like you have to remember or you have to rewrite the different type method based on the runtime of the chain. Then you can have the copy automatically like, generate all the TypeScript type for the interface from those chain metadata. Then you have the connection pooling and also the automatic connections. When you try to connect to a blockchain endpoint, then you have the query and just restriction header, or also a subscription management for real-time update. So that's also like I think that I believe that when you do an AI agent on Polkadot, definitely need some kind of like library, uh, giant library like Puppy. Okay, then another thing I would love to mention is the tool. Then the tool is necessary when you integrate into Polkadot into your Polkadot agent. So the tool we have you can write like balance query tool or use the feature like position builder where you can structure the transactions and allow your agent to side the transactions. Um, or you also have like here population with other step interfaces where you can do different type of stepping operation over ability palette. Okay, here's a symbol where you can write like a symbol like balance query tool for your agent. So you use like the tool method from the language, and then you use like client create the client method from Parity to create a new client with the provider to change, and then you just create the API from Parity then now like the angel agents can already get this response. So like when you ask something related to, hey, can you help me to close the balance of the specific address based on like this two function here, and then like just return the data that you already use happy to track that data. Okay, so here's the process. So you have like the tool is a wrapper that is exposed to the balance. Then you have like the client, where it's playing at the client that connects to the Polkadot provider. For example, if you want to connect to the Polkadot asset, then you can use this provider. Then you have the API, the type API used to query the cluster, and then like later you call the API dot query dot system dot account to get the values of a specific address on change. Okay, and then the another feature that I think like when you build the agent, you have to integrate is the cross-chain messaging or ECM. So ECM enables the agent to orchestrate the operations across like multiple paradigms. The agent not understand like asset location, destination chain capabilities, and fee requirements before constructing a valid message. So like different concept in cross-chain messaging that you would love to review. We cannot like cover in like this presentation, but you can review like for example asset locations where you identify the source chain and the asset type. Before we also like, have one specific video in the Polkadot. I remember it's in like Polkadot podcast or something that we also mentioned about the ECM, so you can review that. And destination check is verify the target chain to support the assets. The fee calculation like estimate the execution cost on both chains before you submit the transactions to, for example, like bridging the asset and like transfer the asset cross chain on a message queue that you can check the ECM with the local limit and then allow like, other accounts to start up. Okay. So here, like we talking about a bit about like Polkadot agent ecosystem use cases. Um, for the agent, like you don't want to just build it as like the whole agent without any connections. You want to maximize like for the tools or the resources they already have in the Polkadot ecosystem. For example, here you have a Fala network confidential agent where Fala allow you to build the agent that only unadjusted as adjusted encrypted environment where like the agent run the computations inside the teams or just the encrypted executions to protect the data. Um, so this allows like confidential computing. The other attribute of Hala also provide to your agent is the sensitive financials and personal data remain confidential. Mm, just the executions. Then like Fala like agent is also allow like just the execution where like you have like a layer with like verifiable integrity for the agent and proprietary algorithms like personalized to stay like protected from the exposure. The other like infrastructure that you can also take a look at is origin cloud. We use decentralized graph. We talked about it in context graph before, but origin shell bring it to the next level in a decentralized manner. So like origin shell offer a relocation or like decentralized knowledge graph that provides like verifiable structured data for agent, which allow like, the agent to access and reason over logistic information, enabling advanced use cases such as like supply chain verification, like identity management, and complex like, decision making based on like the transparent and authenticated data sources. So here we also have some use cases that the origin shell can also verify or like empower the agent. So like it's invalidated agent reasoning and enable the agent to access like reason over logistic data and decision support like drive complex decisions from transparent sources and also like manage the identity of your agent through the different type of the authentication method. Okay, and the other tool that I actually would love to introduce is like the Polkadot Agent Kit, which also we have several workshops and we talk about this too. And the Polkadot Agent Kit is also built by like under like the member of the Open Tool. And the Polkadot Agent Kit like offer a comprehensive framework designed to streamline the development of the agent on Polkadot network. And it's already, have already built modules. For example, the balance query that we talked about before, or like the CM integration that allow you to do, for example, like swapping the tokens on migrations, or like transferring from like Polkadot execute to like different type of change. So it's not have SVM installation already. So basically, like all the features that we talked before already mentioned in Polkadot Agent Kit, and you can simply use the Polkadot Agent Kit to build your own agent instead of like rebuild from scratch. And the thing that I also would like to mention is that Polkadot Agent Kit is supported by the Web Foundation brand. So I believe that this tool is already like verified and qualified enough for users and developers to use it to do something production ready. Okay, so I think that a few goal would be when you bring the agent to production, it's a few things you will have to consider. The first thing would be like team management. Like you would have like the private key agent is secure, and you can either use a hardware wallet or the encrypted vault. And the other thing would be like limiting the element, like exponential backup, for sales and systems, and then respect like the node limits and volatility times. Yeah, so I think like those are like three key points where you can consider building the agent. And there's only a few resources where you can take a look. It's like the Polkadot API documentations, LangChain's information guide and example, so that you can understand how to build a new agent and Polkadot critical specifications. And you can understand more about the Polkadot and how Polkadot works under the hood and as a group and break-down references so that you could, whether you so that you can review question solution. You need to understand how all the change is operate and like the teams like the pickup players extensions like smooth from monitoring or the subject like for local change. Some community you can either go to the open view community or like pick up Discord or like chain community forums. And those are ways for you to be and also like, get enough resources. And you can also like, definitely go to the hackathons Discord and then leave the message there. They'll open your different and help you to support to answer those. And I think that's also the end of my presentation. And thank you for listening. Okay. Okay, I think there's also like there's a few questions here. So I list those. Okay. Can I like tell more about HCM? Um, Yeah, so like, I think I briefly explained that like HCM is basically a protocol allowing you to do like, a secure asynchronous messaging between the two chains. Just imagine like you have a chain A, which is like Polkadot, chain B, which is I guess like Ethereum. But like I said, you need the ECM engine to fit the MO change. But you can think of like you have level two chains and just simply using ECM to send an instructions over like from chain A to chain B. That's like how ECM works. Then like on exchange, depend on like the implementation of the ECM executor, the ECM execute the instruction in different ways. So you need to check like the how the real time these elements like the ECM executor. Yeah, so I think it's really hard to dive deep into ECM, but we can imagine it as like a protocol that allow you to send the message faster in Polkadot. Yeah. Um, Okay, so you're building an event-based time proxy code that automatically, autonomously rebalance portfolio. Yeah, I think that's a good idea. I also like do something similar before. Yeah, that's a really good idea. In this world, you must like think about like, do you want like your agent to autonomously like manage your portfolio and also as a people on chain? Because if you want to do that, then like the key management is going to be important because we don't want to expose your private key to the internet. So you must like, think about the solution. And I think you can either like, look at solution like Unity Safe, where they also like have like key sharding or like key I don't know like key sharding for the agent that you can make your agent more secure. Mm, yeah, I don't know if it's explain your question, but yeah, to leave any questions if it's not that clear, yeah, or like if you need any resources, then I can send material over. Okay, your last question, I don't understand it. Like, should we use the X token to compile, or just send the idle capital across and have a separate differ port on the destination chain to secure the local swap? Yeah, I think that there's a lot of like technical component here. Um, yeah, but like I don't. Yeah, I think I cannot answer this question. Yeah, feel free to leave the question in the Hackathon Discord so that I like more developers or like even I can use your names and to investigate and learn more like how to implement, how to verify the workflow implementation to your solutions. Yeah. Okay, so I think like the time is here. So like there's gonna be a new workshop now. I need to sum up and thank you. Feel free to join. Yeah, like join the hackathons. Like there's something innovative, and then we would love you to see more innovation on Polkadot. And thank you. See you. See you later. Project in the hackathon.
Hey everyone, I'm guessing y'all can hear me. Okay, so just getting set up here. Pardon my setup. Here we go. Okay, cool. So I'm Steve. I'm with OpenZeppelin as the DevRel lead. Happy to be here. Can I just get a confirmation that everyone can hear me before I start going? I'm just looking at the chat here. I'm going to keep going. Okay, so I'll share my screen, and we're going to just go over a presentation today just on secure Solidity development. So basically, before I start, I just wanted to ask quickly here, who has been developing with Solidity for 2 years or so? Or is everyone more new? I guess, I don't know, give me +1s, give me emojis, give me anything in the comments. I mean, I'll wait, I'll continue with the slideshow and the presentation here in the workshop, but it's good for me to understand where everyone's coming from. But essentially, let's just start along. I'm doing that 1.5, nice. Okay. Well, essentially, with today's presentation, right, I want to cover over like what smart contract development has been covering over the last several years. DeFi and everything has evolved a lot in different EVM compatible ecosystems, and now with Polkadot supporting Solidity more in a native way, it opens a lot of opportunities, right, and onboards a lot more developers, and we can even leverage a lot more battle tested code. So with that, what we're going to be covering today is essentially why OpenZeppelin exists. In case, I know I just saw that someone here said that they're, have 1.5 years of experience, but for those who do not, essentially, I'll cover why OpenZeppelin exists and the contract libraries and the whole concept of them. Then essentially we'll cover the categories of building blocks you can pull from, kind of at a high level. And then furthermore, we'll go into secure development principles because, hackathons are a great time to build good habits and go from there. And finally, we'll get practical, kind of just covering using Foundry. That's my preferred kind of framework at the moment with OpenZeppelin, and looking at a real DeFi example. So MorphoBlue or Metamorpho Vaults, it's kind of their V1, but it's a good example just to touch on, because at the end of the day, what I'm trying to showcase is how to leverage, again, battle-tested contracts, whether that be, custom code from other ecosystems in your hackathon projects, or ideally onward, because the goal of the hackathon, in my opinion, and any hackathon, isn't necessarily just submitting the projects for this hackathon. It's also onboarding you into the respective ecosystem. So here, Polkadot, and developing things with Solidity and all of the different opportunities that are available with the new upgrades that have come and are coming with Polkadot's ecosystem today. Okay, so with that, let's get into it. So essentially, and I'll check the questions here and there as I kind of go along, but we'll save the questions for the end if possible. Yeah, so anyways, so why does OpenZeppelin actually exist in the first place? So in general, smart contracts are not like traditional software. And you might be wondering, okay, why is he presenting this stuff again in the middle of the hackathon? I'm doing it because I think overall, long term, I think that once the hackathon's done, we want everyone to continue building. So after this, feel free to reach out to me, and anyone else that has done presentations throughout this this remote hackathon, because we want to encourage continuous building, whether you're doing it for raises, funds, or just for fun in general. But yeah, coming back to it. So essentially, smart contracts are not like traditional software. Once deployed, they're immutable, right? They're publicly accessible, and typically they control real financial assets. So obviously, there's a lot of responsibility involved with this. A hackathon is fun, but when you actually start producing code that has TVL of $100 million, is something that you have to be wary. So effectively, if you look at like the history of DeFi hacks or general hacks within smart contract development, a lot of them come from repetitive pattern missteps, if you will. Sometimes mainly like custom code or missing the way to use a standard library. And essentially from that, right, from ERC20 onward to all the different standards that OpenZeppelin is working on, essentially OpenZeppelin worked with, at that time and currently, with the Ethereum ecosystem on their different EIPs, and essentially came about shared, audited, reusable components that everyone uses today. And now OpenZeppelin actually works with many other ecosystems. Most recently, right, we just released something for Sui, for example, and of course here with Polkadot. So in general, you can look at OpenZeppelin as like this resource for contract libraries across the board for different ecosystems. Cool. So let's look at what's actually in the general toolbox. Again, this is not exhaustive. So overall, the three layers that I'm going to touch on really quickly, because also I am aware that you guys have a lot of supporting docs from the ecosystem within Polkadot. I've gone through it myself, so it's really great. So I'm not going to go through like, the general code walkthrough of ERC20. You can find that where in 2026 we have agentic coding, etc. So more so though, I wanted to talk on like secure smart contract development, because as you all likely know, OpenZeppelin has a sponsorship track in this. And not only do we look for novel ideas of how people are using OpenZeppelin contract libraries, but also we want to make sure that people are actually carrying out proper testing. People can generate all kinds of different code with LLMs and whatnot, but you have to really know what you're doing, because just the smallest line of code error can lead to, hundreds of millions of dollars of a hack. So effectively, as you all know, we have ERC20. So ERC20, though, it has extensions. There's permit, ERC 4626, mintable, etc. Then you have 721. So it has URI storage and royalty extensions and onward. And finally, you have 1155 for extensible multi-asset and gaming details. The key point here is not, again, just the base implementation of each of them. And if you click on the links, I can share the slides after. Effectively, it'll just show you the OpenZeppelin repo and where you can find the details of the ERC20s and the different tokens that you probably are building already with. But basically, there's extensions in them. For example, like I'll show you more in these repos, but essentially, let's see here. Like within Metamorpho, right? We'll look at this later, but 4626 is deep within the extensions for ERC20. I'm just going to glance back to make sure I'm not missing any questions here. Can you share the slides and docs after the live stream? Yeah, for sure. Okay. Let's keep going. So that basically covers like the token extension side. Again, this is not an exhaustive list. This is way back when we created these standards a long time ago. And you'll find more standards within our contract libraries. I'm just going through the high level ones because I'm not sure the range here. I think it's anywhere from beginner to advanced developers. So I just want to make sure everyone's covered. And then the next layer is of course like ownership and permissions. So you have, your basic ownable contract where you set a modifier and you have only owner, etc. And then you have everything for the access control. That's a little bit more complicated, but it's still pretty straightforward, where you define multiple roles with granular permissions. You might have like a minter role, a pauser role, a burner role and onward. And actually, you can actually see this with some of our tools like Role Manager. It effectively can check if we're using different extensions inside of the contracts that you're kind of testing. What I mean by that is, I might as well show you. Let's see. Role Manager. This is one of our tools, for example. I believe we're supporting Polkadot right away. Yep, here we go. And essentially, yeah, you can tie in a contract and start working with it. There's a video on YouTube of how to actually work with Role Manager, but essentially it helps you with access control and more. Okay, cool. Now moving on, and lastly on the layers. So far I've covered there's the token standards, and then there's the there's the overall roles and permissions and ownership layer, and finally there's the upgradable layer. And emphasizing again, you might be saying, okay, OpenZeppelin upgrades, that's great, but that's not really involved with your project right now. We want to encourage further development after the hackathon, right? For Polkadot's ecosystem, as it's in an exciting time. And I believe, as the other speakers have discussed, or have you seen in your supporting documents, there's tracks for grants and other support from the ecosystem as you build. So it doesn't just end here. And when I talk about upgradability, effectively what I'm referring to, if you're not aware, is essentially, since smart contracts are immutable, if you deploy a contract with a bug, you can't really patch it, right? So OpenZeppelin's upgrades plugin for Hardhat basically handles the proxy patterns that makes upgrades possible. It might be really confusing at first when you look at it, but if you walk through the docs, essentially within OpenZeppelin, it walks you through and explains, okay, this is what's going on in terms of these different upgrade details. And since I'm already on the docs as well, you can see the different ecosystems that we support and different various documentation for them. But effectively, for Solidity development, I advise at the moment, at least, to go into the Ethereum EVM section and just follow through. And you'll see all the details I'm touching on really quickly here, and be able to go into much more detail for whatever code, contract, or standard you're interested in. Oops. Okay, and yeah, today I just wanted to mention the plugin for Hardhat. With the walkthrough I'm going through today, again, I initially thought maybe I'll deploy some code with you, but then I want to encourage everything after the hackathon. So this conversation doesn't stop here. Please reach out. So therefore, I'm just reviewing with Foundry, but I just wanted to showcase hey, some of the tools and plugins we have available for you as developers. And then finally, I just wanted to say, in terms of secure smart contract development, honestly, it can be very daunting. And sometimes we think, hey, let's just use a LLM and vibe code, a DeFi project. And it's really awesome for conception. But for obviously really hashing it out, you definitely don't want to be responsible for a hack. So in that sense, realistically, what I've been trying to emphasize is, 1, don't reinvent standards. 2, use audited libraries, whether it's from smart OpenZeppelin or whomever. And 3, minimize complexity. So we'll see this in a bit, but basically, if you haven't kind of noticed with smart contract development, less lines of code is honestly better. Not only on the economic standpoint, because OpenZeppelin, for example, we do auditing, and typical audit firms or services do audits by lines of codes, and that's thousands and thousands of dollars. But also just in general, you don't want to have a foot gun inside of your vault contract for your yield aggregator protocol across the different chains and different parachains. So effectively, you want to try to be minimal about it. And of course, finally, it's test. So with that, I'm going to pause for a second, just see. Hey, can you share? I'm just reading any of the questions here. Any related to Diamond Proxy? I'm using Diamond Proxy pattern. Yeah, definitely follow up after. I'll give my Telegram handle. And if you haven't seen this good spot to mention, the quick one-pager outlining the OpenZeppelin sponsorship package or sponsorship track. We're sponsoring $1,000 USD to folks building using the OpenZeppelin contract libraries, but not in just a simple format, but novel new ways. But yeah, you can find my Telegram handle there and just reach out if you have any further questions about detailed things. Since today we have limited time, I just want to touch on everything possible just to give everyone like a starting point. So hopefully I answered your question there. But yeah, you can find diamond proxy pattern details within our docs and other supporting documentation. Okay, so going back to things. So essentially, now that we've kind of covered like what OpenZeppelin is, the typical libraries and like the layers that we kind of try to think of, the tokens, the permissioning, upgradability, those are just 3 of many different categories of contracts and concepts that we cover. For example, like account abstraction is something of interest nowadays and in the last couple of years as well. You can find all those in the contract library details. Now I want to kind of quickly rip through, and again, quickly rip, because we don't have a lot of time, the different tools that we have at your disposal to help you build fast and safely. And of course, this does not mean, use OpenZeppelin stuff and then you're good for production. I'll touch on that in a bit, but at least it gives you a lot of starting point tools that honestly weren't really available when I started smart contract development, more so like 5+ years ago. So now that Polkadot has like this awesome infrastructure, and in my opinion, and now it is bringing in Solidity development, and it's an exciting time because essentially, again, not only battle tested code and battle tested contract libraries can be brought in, but also like new tools that can really accelerate things, and not just LLMs, although we have like an MCP as well for OpenZeppelin too. So, sorry, quick tangents aside. So now we're looking at the OpenZeppelin contract wizard. Honestly, I'm not going to touch too much on it, again, for the sake of time. But essentially, you can generate automated contracts in less than 1 minute, choose features and get ready to deploy code from it, and also like get boilerplates and error details from it. I'll show you it though. So it's just at wizard.openzeppelin.com. I'll ask here, has anyone used this yet? You guys can answer my questions as I kind of just walk through it. There's a YouTube video already on this. I think a lot of you have actually viewed it for this hackathon. But yeah, as you can see, there's a Polkadot tab, and essentially you can then select the respective tokens, standards, or other different standards that I've kind of touched on, and actually just start making sense of it. I don't know what you're saying nah to, but I like it. So yeah, we can just do jam token, jam, cool, right? And then you can just do a pre-mint, whatever, make it mintable, make it burnable, make it pausable, do all the things. And from there, you give it different roles, and it simply generates your code. Can I get where you can mention? Okay, I'll cover that question after. But basically, yeah, you can generate these a basically boilerplate contract. And honestly, like I'll show you in the last like 5 minutes of the workshop or walk through a presentation here, it is really helpful to get a boilerplate. And let's say you're doing something arguably simple and working with these different extensions, and just want to make sure you're using them all correctly and have the boilerplate functions ready to go. But essentially, I like to use these for more so comprehension and say, okay, like what does it actually look like when I'm using it? Because like you'll see in the example I'll showcase with like Metamorpho, and if you don't know Morpho, we'll touch on that in a second too. Like we are simply inheriting these different like contract standards from OpenZeppelin. We're not really actually like building off of them necessarily like this. Oftentimes we're building some custom logic that is wrapping around it or building the top of it like Lego blocks, essentially. But yeah, that's Contract Wizard. Let's go back here. Essentially, from all that. Oh, okay. Thanks, man. I appreciate the context there. Yeah, so essentially, now we touched on the Contract Wizard. Basically, I wanted to just touch on like the typical hackathon workflow when considering the OpenZeppelin stack. And so I kind of touched it on already, like, well, the first step at least, we are talking about generating base contracts with the wizard. And as I said, for me, I typically actually look at it for more so comprehension. And then from there, you're going to actually build and test with Foundry. So again, you can use Hardhat or whatever framework you're familiar with. I know with with the contract wizard, we actually like link you to Remix to start. In my opinion, Remix is just like a great starting point to understand and get into Solidity development. But later on, you'll get more into Foundry or Hard Hat. And then like, yeah, your final step is deploy to the actual testnet that you're working with or mainnet that you're working with. So with that, that's actually a good spot to start looking at some code for a quick spot. So here, like basically what I've gone ahead and done is started a like staking vault contract. It's very simple. And essentially what I wanted to showcase is one, importing like libraries from the OpenZeppelin contract libraries packages, and then two, setting up a project with Foundry. But again, I also know that you have a lot of these details in terms of at least starting a simple Foundry project or Hard Hat project within your content material. Actually, maybe before I even say anything on that, and I can come back to it, have you guys used Foundry? Have you guys walked through all those content materials? Should I touch on how to set up a project? While someone maybe answers me, I'll walk through what I'm trying to showcase at the very least is simply like, okay, we have all these different contract standards. Again, you can find more by going into the docs and everything. But yeah, you have all these different contract libraries and standards that you'll import into your project. And then from there, you're going to leverage them. Within Foundry, if no one answers me, that's fine. You can just go to the Foundry docs. It's been around for a while, and essentially they can help you set up a project. But effectively what you'll have is like this general setup. So you'll have a source folder, you'll have your test folder for all your Foundry tests, your script folder for all your deployment scripts, and then furthermore, like a foundry.toml for your config setups. And that's pretty much all you'd need. Of course, an env, but since we're not deploying actually in this live walkthrough, no need to talk about that too quickly here. And yeah, and basically within this, I'm trying to showcase like, okay, when you start your Foundry project, you boot it up, you use like Forge init, and then you'll actually get these different folder structures. And from there, you actually just start writing code. This counter.sol, for example, is actually boilerplate Foundry. Is from the boilerplate Foundry project. So you can actually just delete that. And then from there, just bring in your own different contracts. And essentially what I'm trying to walk you through is like creating your own custom projects and leveraging OpenZeppelin contract libraries. So here you can see Staking Vault is actually ownable. It has reentrancy guard. It's pausable. And you can find out more details of them. I already have them highlighted here on the right by simply going into so with Foundry, it uses submodules for dependencies. So if you go to the libraries here, you can actually see all the respective different libraries and dependencies that we're bringing in. So here, for example, we're bringing in ownable. And so I just showcase it here. Essentially, again, according to you, Foundry is most used in industry. Gonna learn. Okay. I'm biased. So my background, I have worked in smart contract development within the industry for several years, and now I'm in DevRel. I'm biased. Foundry is the way I prefer to go about it. I think a lot of different teams do definitely use it, but it seems to be with Hard Hat rolling out different versions as well. Like the two are competing with one another still. So really, I think if you're working with one, you're perfectly fine. Don't quote me on that, but at the same time, in terms of just getting good experience, yeah, I think both are used. Okay, but what I was trying to say is basically, yeah, here you can actually see an example with ownable, right? And if this is all like foreign language to you and you're like still getting to know Solidity, totally cool. It's all good. But basically, right, like you can see here, this is a contract that basically covers like, basically has a modifier that checks whether or not a message caller is actually the owner of a respective contract. So in this case, like the staking vault actually uses ownable. So therefore, if you look up here, right, like only owner, you'll see different respective modifiers on the different functions. How much time do I got? Okay, I really got to go. So yeah, again, I can share this repo after, but again, all I was really trying to leverage and showcase was how one goes about designing custom code. And the way to do it, whether you're using whatever framework, I use Foundry, you basically set up the project. You then, bring in the dependencies. So the dependencies in this case would be OpenZeppelin. I forgot to touch on, within the Foundry.toml, you could also set up like remapping so that you can make this this all nice. You can look into that in Foundry. I actually have that more an example in this one here. So here you can see the remappings are set up so that it knows where to look for the OpenZeppelin contracts in this respective project. And yeah, I just wanted to walk you through like one example of like, okay, look, this is audited code for how to set up like only owner, for example. And I've touched on all those things before and the different contract library standards we have. So you'll be using those respectively when you develop like production level code. That way, the idea is that you want to limit the amount of custom code you actually have and leverage like contract libraries that you do have. Okay, I'm gonna stop on that one now. So a real DeFi example. Okay, so basically I want to make sure we have enough time for questions, but I wanted to at least touch on a real DeFi example because effectively everything that we're creating in these hackathons, and I've looked through some of the builds that you guys are doing, it's looking great. But I think when I look at the tracks that Polkadot is looking at and personal interest, I guess, with where things could go with Polkadot, with cross-chain messaging, and leveraging everything in the ecosystem, it just seems like there's a really great opportunity for building, different DeFi narratives or what have you. And I wanted to showcase a real production example because hackathons, are really exciting. We push out innovative products, but it's a very big difference between a hackathon submission and like a production level protocol that's handling, I think, more of those at like 6 point something billion TVL. So, and TVL's total value locked. And so I just wanted to emphasize and like showcase kind of like emphasize like everything I've been talking about, which is like keep things minimal, use the tools you can to comprehend the different token standards you have. We're in 26, we have agentic coding. Use that all to like kind of create your MVP. But then from that, you need these strict principles of like keeping things minimal, leveraging contract libraries where you can in an audited format, and then basically going on from there and using good testing frameworks and deployment frameworks. And the other thing I wanted to note that I didn't say as well before I just quickly skim over Metamorpho vaults is that the contract libraries are not only good because just they're audited, it's also good because they basically provide, if you haven't noticed, right, obviously with ERC 20, they provide the standard that everyone can build around so that things are agnostic across like different protocols and projects. And we've seen it already, like not only is it native to one singular ecosystem or blockchain, it also extends to all different chains, like cross-chain, right? So in terms of like Polkadot's ecosystem and where it could go, not financial advice, not developer advice, but essentially like what's interesting is that with all these different contract libraries that now Polkadot has exposure to from Solidity development, they can start encouraging like, let's say ERC 4626 standards, and now having like those vault standard tokens in place, and then thus working with like Metamorpho vaults in all the different EVMs. All you got to do is like say develop it, say in Polkadot with Solidity, again using a lot of, you can just fork it and then extend off of their code. Obviously look at their licensing agreements and details, but then from there, right, let's say you have these Metamorpho vaults that are leveraging 4626 token vaults already, or token standards. You could then just have them stitch in and work with like Hyperbridge or whatever to actually communicate with those respective EVMs accordingly, so that you could have like cross-chain DeFi productivity, if you will, with the same kind of standards at the baseline. What time is it? Oh, okay. Well, I don't want to I do want to just showcase it just really quickly, but I'll do it for a quick minute. So it's going backwards. Okay. So basically when I talk about Morpho, and again, I can share the code, What I just wanted to highlight is like here you can see this code actually handles like hundreds of millions of dollars of TVL at one point in time, or still does. And effectively, it's not just the contract wizard and okay, great, deploy it, here we go. It is a lot of custom logic, but arguably actually Morpho does a great job of like keeping things minimal. And essentially what I wanted to highlight, right, was let's just use like deposit. So like deposit. So as an example, I just wanted to highlight this is like simply, as you can see here within my code editor, here's the main function for depositing. If you don't know how Morpho works or Morpho vaults work, the TLDR is it's a vault that sits on a lending market, and essentially the vaults are distributing tokens. So let's say you deposit $1 or USDC inside of that vault, then it will get allocated to the respective lending market to find the best APY or yield. And then from there, you have like a share token leveraging ERC 4626, like the standard from OpenZeppelin. And it's not just so straightforward. They have custom logic in here, right, to decide like, okay, if you decide to deposit, we got to start calculating like how much interest you're going to get, and et cetera, figure out the shares you get, et cetera. But then that's their custom logic. At the end of it, they actually end up, calling _deposit. Let's go to it. That calls super deposit, and super is referring to, the parent contracts involved with this, which is 4626. So essentially it's just a quick example of, that's like 3 lines of code, but it's leveraging this contract library that has been audited and tested and is used as a standard. And so 4626, here it is, right? We have deposit, and you can see in here, it's leveraging all of this to actually work inside of this vault contract. And for sake of time, I think I have to like call it there. But like basically, again, I was just trying to showcase like, yep, you can leverage battle tested code. That's what's exciting about Solidity in Polkadot more so now. And obviously, OpenZeppelin is a composable primitive now that you see it with 4626, ERC20, etc. It gives you the tools that you can want to work with, but then from there you can add custom logic. And beyond this hackathon, yeah, like I keep encouraging, just based off of also my experience, hackathons are a great starting point, but it's not the finish line. And I see with Polkadot's ecosystem, they've always been supportive of grants and pushing out open source development. So highly encourage people to continue building. And with that, that's my presentation. I hope you enjoyed it. Thank you for your time. Is there any questions? It's specific. Also, we're hiring. It's more so for specific roles, but at the same time, we're always happy to chat with those looking to develop in the ecosystem. I'll wait a second for any questions. No? Any way to get wait, you want an intern? These are great questions. But yeah, in terms of working for OpenZeppelin, in terms of like, or working, I guess, in general within DeFi, yeah, there's a lot of nice. Yeah, there's a lot of opportunities, although I know sometimes you can feel like there aren't in different markets. My personal perspective has always been just contribute open source. So you can go to, here, I'll exit out of this here. So yeah, you can go to, it sounds like I just have everyone's time here for a little while, so might as well use it. If you go to like the OpenZeppelin contracts repo, right, you can just find issues and start tackling any of them and raising new ones. And effectively from there, right, we have our Telegram channel as well. And so, yeah, so from there we can, like, we are encouraging more conversation inside of our Telegram channels if you're working on an issue or what have you. And then from there, my personal opinion and what I've seen kind of work for people, I won so many till now. Fair. Yeah, in my personal opinion, it's about creating, like, finding projects that you specifically are interested in. So whether it's OpenZeppelin, I think it's a great company, but obviously there's many projects in the crypto space. Finding that project, let's say a project within the Polkadot ecosystem, and really digging deep into them. And with agentic coding and everything, it really gives you the opportunity to build whatever you want with them, and just start to build something that you find interesting, and from there showcase it, whether that's through expos or what have you. Showcase it and discuss it with the respective projects. People's discords, they're very responsive typically, and everything from there, and that honestly gets you kind of a foot in the door. I'm not going to lie, that's how it's worked for myself as well as other developers I know. So yeah, that's just my food for thought. I'm happy to stay for a little bit longer if there's any other questions. Just kind of looking here. Yeah, no worries. Okay, sounds good. I'll pass it off then. Thanks for the transition there to Husni from Polkadot UX. Thanks, everyone.
So yeah, hello everyone. So good morning, good afternoon, good evening, wherever you are. Can you guys hear me? While I'm just trying to share my screen. Yeah, great, thanks. So yeah, so the last session of the day, it's not going to be very technical, so bear with me. It's going to be probably quite simple as well. And it's going to be touching something quite differently from the stuff that we already talk about. Sorry, I'm just gonna think. Yeah, wait. Just gonna start presenting that. So, yeah, this one should be good. Can everyone see the slides? Yeah, okay, it looks good. So yeah, we're going to be discussing the other track that the hackathon offers, the PVM track. So what is PVM? PVM is Polkadot Virtual Machine. So it's essentially its own native virtual machine, comparatively different to the EVM or the Ethereum Virtual Machine. But we are not going to be touching on that specifically on the smart contract side because I'm going to mention why down the line. But this smart contract that's written in PVM, that's written by one of the, I think it's like the educator at Web3 Foundation. He just wants to create this proof of concept by writing a Rust-based smart contract that compiles or targets RISC-V on PVM. With a really simple example, right? You guys have known this. I'm pretty sure even if you've only learned you're only learning smart contract is the flipper contract. So basically just flips a value, a Boolean value from from true to false, and the other way around. And you guys can also look for the repo that for the POC that I've written. So essentially here I'm building the front end for this smart contract. And why I'm building this, I'm going to elaborate this in this session as well. And I've actually created like a better breakdown of this repo itself in a full article that I've just I think I published this morning, European time. So you can guys go ahead if you feel like lost afterwards after this presentation. You can refer to that article as well while looking at the repo to understand better the reasons and the goals of that of this proof of concept. So yeah, let's move to the slide. And yeah, so we know this flipper contract. So this is like a really basic hello world of the smart contract world. Like I said, it's toggling a Boolean value, which is true or false. But something that is special for this smart contract is that it's written in Rust in a no standard environment, which is compiled to RISC-V. So this is like a different architecture of the at the processor side, I would say that is that runs on top of Polkadot virtual machine. Since it's a very new, I would say a very new tech in Polkadot, so not very mature. I don't think there's any front-end tooling yet that would help you to bootstrap adapt really quickly, which is I think it could be a very nice edge for you to as a hacker for this hackathon, especially given that they have this specific PVM track. And this is where it plays out, where I'm gonna be honest with you, I'm vibe coding this, but essentially with senior level you know reviews. So I'm making sure that it's not doing something weird down the lines, at on the back end or something like that. So I try to pair this with the Next.js front end. And since PolkaVM has this EVM or Ethereum compatible layer using JSON RPC adapter, I think we're going to touch on that a little bit later. So it helps that the Next.js app actually it's very quite minimal, I would say. So with the matter tooling that Ethereum has, like for example, WAGMI or VM, we can already interact with the dApp itself, which is quite um, you know quite amazingly. It's built on Rust instead of written in Solidity. So yeah, if you're interested to look at the nitty-gritty details of the Rust contract itself, I would recommend the guy, like I told you about, who wrote this smart contract in Rust, um, that is successful. I use his post as well to test it myself, and it's really easy to just follow through this. The link is on the slide itself. You can go there and then try it first, like understand how the contract works. I believe that there's some like they're using some macros and some flags that you will need to understand, but then it will call through this I would say like this like implementations on Rust if you understand Rust, where it will try to call this layer, the compatibility layer of Ethereum. So it try to actually translate this so binary, so the Rust binary to EVM bytecode, so it can seamlessly basically call this contract with Ethereum style calls. So it's trying to bridge the gap that is even though even though that you writing Rust smart contract, you can still have Ethereum like interfaces. So it's great for Solidity developer. That's what I'm trying to say. So then you'll be asking, why would I need to build a front end? Well, because even if PVM is great, writing smart contract in Rust is cool, you don't want to, especially users on a daily basis, they don't use CLI or terminal to interact with Web3 or dApps, right? So we need better accessibility, and the front end is a way to do that. And another thing is that if you want to debug, probably you can make sure that your smart contract is safe, it's properly audited, but then there are some quirks that might, hiding in the UX side of things, and you need to make sure that and ensure and verify that with the with the working UI or front end code base, right? And then it's also a way for you to be able to say that now you're in hackathon. If you're just building the smart contract itself, that's cool. The system works great. Nothing breaks. You have, it works with Polkadot precompiles. It's doing some kind of like XCM, very, very nice. But then it's not very easy for you to demonstrate this because I think you need to create a demo video as well. And building a front end is also another way to, clearly show this, showcase this with a very beautiful or, layouts and styling of the front end itself. And another thing is that you can also show the judges that the Polkadot itself, even like with the sleek front end that you've built, you can prove that Rust and Solidity can, play along well together on the same environment or on the same testnet, which is pretty cool. So yeah, I think it's another upside that you can gain by building a front end that works in both EVM and PVM. And the tech stack for this project that I've mentioned, the POC that I've built, it's just very simple. I think most of you are familiar with this, like the front end, the basic stuff, like with Next.js, React, and TypeScript. The only difference is I would say that that's not very common. I would say that writing in Rust with no standard development, because I think this one should be compiled to WebAssembly or something like that. And in WebAssembly environment, you lose these standard libraries in Rust. So that's why. And yeah, it's this stuff will be handled with just a couple lines of code, and you can still use Foundry in this to to interface with the smart contract for interface with the smart contract, either to read or write to the smart contract itself using CLI. So that's cool. Props to the DevX team at Parity. And the Web3 layer, more on the front end side library. We're using the standard libraries again, for getting hooks with WAGMI, and using the VM for calling the contract. So this is basically like Foundry, but on the smart contract layer. No, on the front end layer. That's what I would say. And we are just basically interfacing or communicating with the JSON RPC adapter. This is the compatibility layer that I was talking to you about on the Polkadot testnet. So this is why this POC is important, because there's no front end library yet that is dedicated for PVM. So what's going on this project? So basically on the UI, I'm going to show this quite soon. I think I can just, well, a Flipper contract is very simple. So I'm just gonna share the screen. So bear with me for a while. This one should. Uh, yeah. So this is the very simple dApp that I've told you about. I haven't deployed this anywhere, so you need to go to the GitHub and then set up the project and then run it yourself. But it's going to be very easy, very fast. But essentially, you can just use MetaMask. This is a PVM contract. You can just after already deployed this, you can open this on the Block Scout on Polkadot testnet. It has already done some transaction, so basically just flipping stuff up using the same key that I have. Make sure that you go to the docs as well, because I think you'll need to first set up the Polkadot testnet. I'm pretty sure that you've done this already, because it's already 7 days before the submission, and get your testnet token, because otherwise you're not going to be able to interact with the testnet. So yeah, with a simple UI, and it's just reading the value that is polling through the decoded events for the transactions that for the storage on the smart contract side, and I just added like one small feature where if you flip, you cannot see the MetaMask, but I'm confirming anyway. So yeah, it's starting to confirm, and I think I can share this on another way. So by the window, I think, or the entire screen. I think this one should work. Um, yeah, let's see if it works. You can see that I'm trying to. So yes, trying to confirm, and then it will tell me that it has flipped the value to true. I think the last transaction flip it to false, and then it came back to true. And I did like on the code base this event in or some kind of like indexer that, but it's actually just polling the last events. You know, the one that has been confirmed and has not been processed yet by the front end. And it will just, you know, put out some timestamp, flipping what kind of event that has happened. And every time, so basically every time you click this button, you confirm, it's going to be shown here. So the second transaction would be flipping to false with the timestamp. It's very basic stuff, but it just goes to show that you can very easily already interact with the smart contract, although it's written in Rust. Basically, you just need to write the Solidity interface for this smart contract, because essentially that's the entry point for your you know, for your Ethereum based libraries like VM, to be able to either read or write to the smart contract that you've just deployed. So that's quite cool. Just going to go back to the slides. So yeah, this is just the whole architecture. You click the flips, the hook is going to help read by using like hooks that are already available, and it will encode the calls. It will send it through the you know, the compatibility layer through the adapter, and then it will be read by the palette, the revive palette. This is the also another compatibility layer, but that lives on the runtime, and it will execute the bytecode that is on Rust binary, and the storage of the flip, you know, so storage got updated, the event emitted, and then on the front end, like I told you before, it will just get the latest state using the, you know, using the library that on top here, and then it will refresh the state of the UI. So very simple, but very cool, you know, proof of concept that has not been shown anywhere. So yeah, we have the code here. I think you can go to the code base and then you can just snapshot this slide. We have the flipper, you know, the .rs, the Rust smart contract. That's just basically a getter and then, you know, a setter in terms of flip that is emitting an event. And this is you know, just the ABI that you need to define as well, so that Veeam can encode, you know, some calls. And there are some, this one, I think this is for the ABI as well, dependency in Rust. And this one is for the JSON RPC adapter for in terms of library. So for the front end side of things, I'm just using for all of that three hooks. So reading the accounts, reading the contract, and writing to the contract. So pretty simple. I think there's not a lot of you know, difference with when you're writing Solidity contracts. And I'm just reading the contract address. It's quite safe from the env and the RPC URL, because I showed this on the dApp itself, so that you can verify that this dApp is actually, you know, it's not a trick or something, but it's actually interacting with the blockchain. and some React query to make things faster on the front end by catching and then refetching stuff. So it's like I told you, if you really want to see how this works and to probably inspires you on what to build, especially on the front end side, when you have written your PVM Rust contract, you can just clone this and then go to the contracts library, contracts directory, build the contract. It will generate the binary that specifically target RISC-V on the PolkaVM virtual machine. And you can just simply deploy by, like I said, you have already set some test account with this, with this test token, and then you can just set this up using Foundry and then cast it so that you can deploy this to the Polkadot Hub testnet. And then you go to the front end and make sure that you note down first the deployed smart contract address, and you set it up on your front end on the in the environment files, and you can just simply run the front end by just installing the dependency and then run the dev server. But there are some pros and cons on this project, of course. The very important ones are you can just, by the grace of the Polkadot Ethereum compatibility layer, using their JSON RPC adapter, you can just use the common libraries like WAGMI and VM just without any other hacks. Like it's very simple. Just config it. You can see it on the code base. I can show you later as well if you want. And then you can just call the necessary function calls, or kid encoding and decoding uh, functions that you need to be able to show that in the UI, or to make some buttons be able to interact with the getter or the setter function. And yeah, and the other stuff is very standard front end front end development workflow. So there's nothing new about it. But the other side of things, some pitfalls that you need to be aware of. The opcodes differences between Revive is on the Revive palette. It's subtly different. So there might be some unexpected errors or something that you should be aware of. And from the docs, I think I mentioned this on the article as well. I'm recommending you to go to the article as well for deeper dive. Some So if you want to be able to interact with, let's say you want to make a smooth UX and have this like a native interaction with the runtime, Polkadot runtime. So essentially accessing accessing the blockchain features of Polkadot Hub, like the native assets or the XEM calls. Then you would probably need native Polkadot accounts, and that need manual Ethereum mapping. Go to the docs; they will lead you to it. It's just like quirky details, but you need to do this anyway. And there's some like with the since this is there's this compatibility layer, it will add latency as well. So be wary of that. And on some toolings that helps with the smart contract side. This is not necessarily related to the front end integration, but for smart contract, you'll need to some workaround. You need to do some workarounds for deployments using Hardhat. So I would say that the cons is that some toolings for smart contract deployment and development are there, but it does not yet cover every possible level that you would think of when you're writing Solidity on Ethereum. So yeah, make sure that you're well informed about that, and be sure to always refer to the docs. So yeah, key takeaways for this. I would say that the POC that I've just shown you, and with the code base, looking at the code base, I think it is solid proof of concept where we can write Rust smart contracts, and that are they can already talk, or that can already um, that can already has an interface with the front end that is very like quite smooth. You can already create like some dApps on top of it. So yeah, it's quite cool. Definitely try to tinker things with much more complicated smart contracts, like for example, like I don't know, governance, proposal voting, or lump sum cross-chain token swaps. I think it's definitely doable. And the technical side of things is something that you need to figure out yourself. Well, that's basically the whole idea of hackathon. But I'm pretty sure that the infrastructure is there. The tooling is almost catching up. So all you need is your idea and your grit. So yeah, like I said, the tool is there, and then it's maturing fast, and expect that you'll probably have these PVM dedicated front-end library soon, brought by the core team, or an idea that I have in mind is that probably you could build it yourself that can be eligible as a hackathon project. That could be cool as well. So yeah, it's a great starting point, this code base for anyone that's exploring this new frontier for Polkadot apps, because it's everyone has been looking forward for this. New virtual machine that's more robust, that's more optimized. So yeah, please explore this new frontier. These are the resources. So I have my GitHub repo. Please feel free to fork it, and then pull it on your local machine. Try it out. Very simple. I think it will only take like 5 minutes of your time. I have created a full breakdown of the code base itself on an article on Dev2. If you have more time, feel free to take a look at it, comment on it. If you like it, and then please give a like. And the backend side of things, it's mostly built by battery self. This is something that's important as well. I think you want to build PVM smart contract, so you need to be able to understand at least how to write a Flipper smart contract on Rust that's deployed on top of PVM. So check this out. And if you got lost, of course, the docs is the way to go. I think it's always updated regularly. So go there if you got lost for first class support. And there's this another, I think, can we open this? There's also, just to give you an insight, or between EVM and Revive palette. So Revive is just, let's put it in simpler term, another way to say PVM, but it's just a palette. So this is like a business logic that sits on top of the runtime of Polkadot Hub. And then it will give you a breakdown between those two things. So PVM versus EVM. So if you're coming with a solidity background, you can understand, some quirky differences and why they are taking, these, I would say, taking these compromises, and how it affects the code and how the system works. For those of you who really like to go into the, low level stuff, I think this is something that is interesting. There are other stuff as well related to the Revive, compiler, um, Revive compiler layer. So that's good. And yeah, I think that's my last slide. I leave it to the chat if there's someone who wants to ask some stuff. If you want me to go a little bit to the code base, because I think I'm running out of time right now. Thank you. Yeah.